I'm Rebecca and I'm a maths tutor at the Learning and Enterprise College. Did you see the pink supermoon recently? It was beautiful, and when I saw it and I watched my lovely colleague Jude's video about the rice and the chessboard, which you can see on the college social media sites, it made me think about other ways that we can visualise exponential growth, which is really important in the news at the moment because it's helping to explain how the coronavirus has spread around the world quite so quickly. So I've got here a sheet of A4 paper. Now, if I wanted to measure how thick it is, what unit of measurement would I use? Well, I'm going to go for millimetres because it really is quite thin, and I know actually that it's 1/10 of a millimetre, which I can write as 0.1 millimetres. I'm going to fold it in half. And now if I were to measure it, its thickness would have doubled to 0.2 millimetres. If I were to do 2 folds, its thickness has doubled again, and now it's 0.4 millimetres. 3 folds, and now I'm on 0.8 millimetres. 4 folds, and because it's doubling each time, it's going exponentially, it's 1.6 millimetres. 5 folds would take me then to 3.2 millimetres. 6 folds to 6.4, and 7 folds would take me to 12.8 millimetres. Now you might look at those numbers and you can see, you might know that 4 is 2 squared, 8 is 2 cubed, 2 times by 2 times by 2, 16 is 2 to the power of 4, 32 is 2 to the power of 5, 64, well 6, which we got from 6 folds, is 2 to the power of 6, and 128 is 2 to the power of 7, which we got from 7 folds. So if I was going to fold my piece of paper 17 times, I could use this to help me work out how thick it is. Be 2 multiplied by itself 17 times, 2 times 2 times 2 times 2. Well, I've done the maths already, and 2 to the power of 17, or 17 folds my bit of paper, would actually take it to 131 centimetres high, which is roughly the height of a 9-year-old child. So in just 17 folds of paper, so 17 folds, this piece of paper has gone from being a fraction of a millimetre to as tall as a child. If I was to fold it 25 times, then the growth is enormous because it's growing exponentially, it's doubling each time. 25 folds would make it 33,554 centimetres, which is roughly the height of the Shard or the Eiffel Tower. So just in 8 folds difference, it's gone from the height of a child to the height of a really high building. If I was going to fold this then 30 times, the number's now so big that centimetres isn't really a sensible unit of measurement, and it's 6.7 miles, which is roughly how high planes fly. 15 more folds and the growth is enormous again. It goes from being 6.7 miles to 250,000 miles. Which is where the moon comes in, because 250,000 miles would mean that this paper was high enough to reach to the moon. So how many folds would it take to get to the moon and back again? Well, it's doubling each time. So instead of 45 folds, it would take 46. And that's how exponential growth works. I hope you've enjoyed that. Thanks very much for watching.